Hello, it's Islas Ahmed Nawaz here again for another tutorial. So today I'm going to be walking you through another system I've created. Essentially, it's just facial recognition slash fingerprint scanner, and essentially I've called it sentinel-lock. Essentially, all it is it's a biometric door access system with face recognition and fingerprint auth, all written in Python. So this video is a full end-to-end demo of the prototype, the enrolment, the face unlock, the touch ID, and also the security layer. So yeah, so the stack primarily is Python 3.12, FastAPI, InsightFace. So we've got SCRFD and ArcFace as well as OpenCV and SQLite. I've got Fernet as the encryption. So they're strict mypy ruff. So I've got about 58 tests in total. And this is behind the injected interface. So yeah, as you can see, I'm running it locally on port 8100. So just to kind of go through it, so we've got the unlock here, and so I'm gonna lock it right now with my face. So look straight into the camera. So I'm just gonna put my preview on just so that it allows everyone to see how it actually works. So look straight in and you can see, yeah, the door's unlocked, right? So for each actual frame, it computes cosine similarity against all of my stored templates, and then it takes the best. So across frames it takes the medium, and that median of best aggregation means that there's one blurry frame that can't sync a genuine match, and one lucky frame can't fake one. So just gonna put that preview on again. So let's say unlock with face. Obviously right now I'm just covering my face with my hand. It's not obviously, as you can see, that the error message came on there. So let's say I've already enrolled my finger. So let's just say I've already got that anyway. So for demo purposes, I'm not gonna obviously go through that again and compromise the security of my token. So yeah, as you can see, so right now it's locked, but right now I'm on my Mac, so it will unlock here. So yeah, the similarity of this is just against you know, when it does when it does grant it, so it's against a threshold of 0.4. So the provider hands that to the access controller, which then checks the confidence flow, the lockout state, the cooldown, and then it actually actuates the lock and schedules the relock, and that countdown is polling you know, the real service state, not a front end animation. So yeah, that is pretty much from the end to end. So I'm just kind of gonna go through the code now. Um, so just gonna go through a bit more detail there, and so that it makes a bit more sense. So I've got here the base.py and the controller.py. So here, the base.py on my left, this is the design rule number one. So we've got recognition code that actually never actually touches the lock. Let me put down the terminal so it's a bit easy to see. The auth providers, so the face fingerprint, you implement one interface, enroll, and then verify, and then it actually just returns you know a match result with the confidence score, and that's all they can actually do. So the only component that's allowed to actuate the lock is this access controller. So there's about 100 lines. It's fully unit tested. Well, just under 100 lines, and we've got, it's unit tested. Essentially, I've enforced a per method confidence flow. I've got a failure lockout here as well, and a cooldown between the grants, and this writes every decision. So the grants and denials to an append only audit log in SQLite. So it's quite good, to be fair. It's quite a good system. So that is the base.py. On my right, I've got the controller. And yeah, it's pretty much, yeah. Well, this is just over. on the lines. And yeah, it's pretty much as I said, it's fully unit tested. It enforces pair method confidence flows. There's a failure lockout, there's a cooldown between the grants, and then yeah, it writes every decision. So I'm just kind of gonna go through the next step. So so obviously I've enrolled my face. So as you can see, when I enroll my face, OpenCV is essentially pulling frames off the webcam and then running them through InsightFace. As I mentioned, SCRFD for detection, ArcFace for embeddings. Every frame essentially passes a quality gate, so exactly one face, a detection confidence above the threshold, and there's minimum bounding box size, so it keeps the 8 passing frames, spaced at least 250 milliseconds apart, so I naturally span slightly different poses. So, and each one becomes a 512 dimensional L2 normalized embedding, and each is encrypted with Fernet before it ever even touches the database, and the key lives in the environment, not the repo. um and I've just got this order log here, just kind of makes it a bit easier for me to kind of keep track of everything. So just kind of reiterate on the fingerprint. So on the Mac, I'm back in the same provider interface with the Touch ID sensor through Apple's local authentication framework. So currently, the machine I've got is a M4 chip, and this essentially, it's already got a fingerprint system in there anyway. So I'm just using that just for the ease of this. So matching happens inside the secure enclave, so the OS never actually exposes the fingerprint template. So enrollment actually binds this machine's touch ID to a user, and then a successful evaluation verifies as that user. So on the Pi, the same interface is implemented by the, you could say, the R503 over UART. So where the sensor does its own on chip matching. Either way, the application only ever sees an identity and a score. There's never any biometric raw material. So let's say, I've already gone through when it's not me, but let's say I'll go through and currently I'm using my index finger now, so that's why it's, you can see now. There's not going to be no match, right? um so that's obviously why the issue I'm seeing here. And there's the logs here, all of you 200 showing okay, which is always, it's always good to see. um Obviously the audit log is a hash chain, so every entry's hash commits to its own field plus the previous entry's hash. So the same construction as a blockchain minus the consensus theater. So it's quite cool, to be fair. So I can reset the lockdown. um I've got the admin token somewhere, and yeah. So I'm just kind of gonna go through the code in a bit more detail. So when I go to rough check, it's in the VN anyway. Just activate the VN. So yeah, as you can see here, when I do the rough check, the whole thing is Python 3.12. So we got FastAPI, strict mypy, rough, and as you can see, there's about 58 tests here. So the access control, the decision logic, the matching math, the crypto, the yeah, the hash chain and the full API flow all run without any hardware. And I think that's the beauty of it. It's a well-oiled machine, you could say. I made sure to test every little thing. So because everything of your hardware shape is injected, same suite runs in CI on Linux, so which has no camera and no touch ID, and then that's the abstraction essentially proving itself. Um, so yeah. If I kind of go into the next files, if I go into if I go into let's close these bad boys down. Um, as you can see, so I'm just gonna go here. I'm just gonna open up on the other side as well, the fingerprint as well, and let's make this. Okay, so essentially every piece of hardware here, as you can see, we've got the GPIO and the fingerprint Pi. So every piece of hardware sits behind the interface. So the camera is a frame source, the lock is a essentially lock control, and the fingerprint sensor interface mirrors the R503's actual UART command set. So there's an on-chip template slots, and I've also got a one-to-end search retaining that slot and the score. So when this moves, essentially what this is, I'm gonna get the hardware for this, and going to use Raspberry Pi 5 with the Pi camera and the real R503, and these are just the three class swaps. So there's zero business logic changes. So yeah, I mean that's pretty much the nitty gritty of it. So unlock the face again. So I'm looking straight at it. Just show you. Let me just unlock it again. Let me just put my hand in front of my camera, and I think we should say access denied. So I got my hand in front of my camera, so it shouldn't, yeah, access denied. As you can see, now I got my hand, well, I've just got my face there now, so it should, yeah, cool. So preview off now. Same thing with the touch ID. So facial recognition. And what you can see is, as you can see, the door, when it's it's not verified, it's locked. When it's verified, it's unlocked. So yeah, this is a sentinel-lock. It's a biometric door access system that I'm building. Face recognition and fingerprint auth on the left. Eventually I'm going to be driving a 12-volt electric strike on a real door. Today I run entirely on this MacBook. Webcam for the face pipeline, the touch ID sensor for the fingerprint, and a simulated lock. So yeah, thank you for watching today, and yeah, have a lovely day ahead. Cheers.